Hi, Mr. Kane here, and we're going to explore what actually happens when you mix an acid with a base. What's going on chemically wise, and how can we use that? So we met before the idea that acids destroy bases, bases destroy acids. They're chemical opposites. They neutralize each other. It's part of being this chemical opposite thing. Opposites cancel each other out, and they neutralize each other. The bases cancel out the acid effect, the acid cancel out the base effect. So this links the pH scale here. If I've got a really strong acid, I can add base to it and bring it back to neutral. So if I have an acid down here somewhere and I have a base here, if I add this base to this acid, it's going to make it weaker and weaker and weaker, so eventually I get to the neutral point. So if it's a weak base like here at 10, I have to add quite a lot of base from here. If I'm using a stronger base, I don't need to add quite so much. So depending on how strong or weak the acid or base is, what I'm adding to each other depends on how much I have to use. But they'll cancel each other out, and the acids and bases will end up cancelling out, and we'll have a neutral thing in the middle. As long as if we're using indicator, we'll tell when it gets to green and when things are neutral, when things are safe. So let's look at that. So acids and alkalis reacting, one's cancelling out the other, given the fancy name a neutralisation reaction. For example, the word equation, the general word equation that applies to all neutralisation reactions using acid and alkali is this: acid and an alkali, you'll end up with a salt and water. Now when we think of the word salt, okay, think of this word here, the salt, we're commonly thinking of this salt here, sodium chloride, which is actually table salt. But chemically speaking, there are lots and lots of different salts, and it depends what acid you use, what you end up with. But acid plus alkali, you'll end up with a salt plus water. Notice I said a salt. I didn't say just salt. When we say just salt, we're often referring to table salt. So in this example here, we've got hydrochloric acid being mixed with sodium hydroxide. Of course, the hydroxide, I'll just get rid of the hydroxide and the hydrogen ions, they go together to make our water, and the chlorine and the sodium, they come together to make our salt. So the metal part of the alkali and the other part of the acid go together to make whatever salt it is that we end up making. And the hydrogen ions and the hydroxide ions cancel each other out and leave us with water. So a salt is made. Depending on what acids and bases we use, it depends on what salt we get. So, like I say, depending on what acid and alkali, depends on what salt. The salt's got the metal atom from the alkali and the other part of the acid molecule. So sulfuric acid makes sulfates. So if I added sodium hydroxide like before to sulfuric acid, I would get sodium sulfate. The example before shows sodium hydroxide being added to hydrochloric acid, and I got sodium chloride. If I added it to nitric acid, I'd get sodium nitrate. So it depends what acid we're using. And these are the three common lab acids. So sulfuric acid gives you sulfates, hydrochloric acid gives you chlorides, nitric acid gives you nitrates. Look at the alkali being used. What is it? What metal's in there? So for example, I was using calcium hydroxide with sulfuric acid, I'd have calcium sulfate. If I mix it with nitric acid, I'd have calcium nitrate. So as long as you know which one you're using, you'll know what to call the product. So how can we apply this? What can we do with it? Have you ever been stung? Okay, insect stings. So bee stings are acidic. If you got stung by a bee sting, baking soda on it will neutralise that, because baking soda is the opposite of acid, and you'll neutralise it. However, if it's a wasp sting, it's alkaline and you've got to put some acid on it. Easiest one to find around home is with vinegar. Similar sorts of things with jellyfish stings. If you know which jellyfish you've been stung with, you can neutralise the effect with either a base or an acid. And often, sometimes on some beaches, especially over in Australia, I've seen containers of vinegar around the beach just in case someone's been stung by some of the stingers over there. So, oh, what's that in my stomach? I'm not feeling too flash. Indigestion. We've got hydrochloric acid in the stomach, and too much leads to indigestion. It's escaping into the gut system. If it comes up into the throat, we get heartburn. Not very nice. If it goes out of the stomach, down through the gut system, and it's getting too acidic there, we've got a gut ache. It's not feeling comfortable. Indigestion. So we need to cancel out that acid. So we neutralise it with some baking soda, mix it in some water, drink that down, that'll help. Or we've got specialised indigestion tablets. An example here you'll find in shops is called Quickies. Chew on those and that will help settle things down from the too much acid out of the stomach. So that's how acids destroy bases, and they're opposites, remember, and they neutralise each other. And some applications and what's going on, and some information about how to figure out what salts are being made. I hope that's been helpful to you, and thanks very much for watching.